Hey there, this is Math 7, Unit 5, Lesson 1, the extra homework packet for Clovis Unified, interpreting negative numbers here. Oftentimes when we do these here, the first question is one that I might talk through, but I'm not going to do because it's a review of the lesson to kind of see what you got from that lesson here. So this one here, it says, here's a set of signed numbers. We have 7, -3, 12. I actually think this was supposed to be written as a half. So you might have that changed on your notes from your teacher. It was supposed to be a 12, I don't believe. Negative 0.8, 0.8, negative 110, and negative 2. And they want you to first of all order the numbers from least to greatest. So that means we're going from smallest to largest. Okay, and put those in orders there. If these numbers represent temperatures in degrees Celsius, which is the coldest? So coldest, think about what the coldest is going to be in terms of is that going to be the high number or the low number, right? So think about what that's going to mean there. And if these numbers represent elevations in meters, which is the farthest away from sea level? So you're in that case here, you're thinking about a distance. Let's just draw a little picture here, okay? So here to here, sea level is going to be at 0. So you're trying to see, okay, which one would be the furthest away from 0 from that point right there? Okay, so it could be on the negative side, could be the furthest away, it could be for a positive number, the furthest away. So which one is the furthest away from sea level? Let's look at number 2. A whale is at the surface of the ocean to breathe. Okay, we have this little chart here. So here's our whale right here at the surface. So it's at 0. That's where the whale is at, having a great time there at the surface breathing. What is the whale's elevation? So at this point we would say it's at 0 feet. Okay, if he's right at the surface, then he's right there at 0. It says the whale swims down, so we're going to be going down 300 feet to feed. What is the whale's elevation now? So at this point, we would look at this and say, well, it went from 0 and it went down 300 feet to here. And it is labeled here, the 300, and it's really hard to read on my chart, but I think there's a negative sign there. We would say that he's negative 300 feet. Which is a way of saying he's 300 feet below sea level. The whale swims down 150 more feet. So we're going to continue here from this point on and go down another 50, 100, and 150 to this point right here. Alright, so what's the elevation at this spot? Well, this spot here is going to be at negative 450 is where that whale is at now. Plot each of the 3 elevations as a point on the vertical number line to the right and label each point. Alright, so we had the whale was here, and that was at A. Then the whale went to here for part B, and then the whale went here for part C. Alright, and that's how we would label those and do those. And it's good to see this little number line working vertically to show the difference here between where the whale is at with the ocean, under the sea, or above the sea. Right now, he's staying under. If he was to jump up, we might be able to count him up there, but probably not 100 feet. All right, let's look at number 3. It says, is a temperature of negative 11 degrees warmer or colder than a temperature of negative 15 degrees? So thinking about a temperature, okay, if we're at 0 on a number line, okay, and here we are at negative 11 and negative 15 is further over here. This is definitely cold, and we're going to get hotter the more we move towards this side here. So the more you are to the right, the warmer you're going to be. That doesn't mean it's warm, but it's definitely warmer, because negative 11 is actually a greater number than negative 15. Okay, it's closer to 0. Okay, so it's a greater, larger number, which in terms of temperature would make it a warmer temperature. For number 4, is an elevation of negative 10 feet closer or farther from the surface of the ocean than an elevation of negative 8 feet? Alright, so again, thinking about elevation here, if we're at 0, and that's the surface of the ocean, and we go down here negative 8, and here's negative 10. If we were to think about there and think, okay, which one is 10 feet closer or farther than 8? Well, it sure seems to be farther away than 8. 8 is closer to the surface than that one is, so we'd say it's farther away. All right, number 5. I'm not positive on this, what they're looking for here. I think these are supposed to be degrees as well. I want to say this is negative 20 degrees and a 12 degrees. And so I think these are all comparing degrees, even though they don't say degree except on the last one. Just my thinking. So we're looking really comparing at the numbers here and deciding if the statements are true. That's what we want to find out, true or false. Is negative 20 less than 12? We would say that's a true statement. Negative 5 less than negative 0.5. On a number line, that looks something like this. Right, here's 0. We have 1, 2, 3, 4, 5. There's negative 5. So that one's going to be right there. Negative 0.5, though, is like a negative a half. That's going to be right there. So we would say that this number is indeed greater than that one. That's a true statement. And then finally, in the last one here, we have positive 1, which would be here. Here's 1. Compared to negative 7, which is over here. And they say positive 1 is greater, and that would be a true statement. All right, number 6. It says, well, this is a review one here, so you can figure this one out a little bit. Let's read it real quick. A map of a park has a scale of 1 inch to 100 feet. So 1 inch on a scale, let's say it's like this, is equal to 100 feet. Another map of the same park has a scale that says that this 1 inch is going to be 50 feet. Which map is going to be larger in terms of the size of the map that you create there? Well, think about this. We're putting more stuff, 100 feet worth of space of park inside that space here, and here we're putting 50 feet, which means this same picture, let's say that I had a basketball court that was 100 feet, okay? It would be this size. But a basketball court here would end up being this size. I'd have to double that to get two 50s together. So just drawing the park, this map here is going to have to be larger than that one based upon the scale that's being used. Let's look at number 7. We have Han uses a quarter cup of orange juice for every half a cup of pineapple juice to make his favorite fruit drink. How many cups of orange juice does he need if he uses 1 cup of pineapple juice? So we have our orange juice, and we have our pineapple juice, and we know that our ratio here is a quarter cup of orange juice goes for every half a cup of pineapple juice. That's what we know. That's our regular ratio to make the fruit drink. He's going to use 1 cup of pineapple juice. So we're going to put a 1 right here in our table. Right? And I ask myself, how do I go from a half to 1? Well, I multiply by 2. Okay, so I'll do the same thing over here. I'll multiply 2 times 1/4, which gives me 2/4. Another way of saying that, reducing it, is a half. So we would say it would take half a cup of orange juice to get that worked out. All right, let's take a look at number 3. I'm sorry, 3. Number 8. It says find the circumference of the circle. So circumference is found using the formula pi times the diameter. Now in this case here, we see that we have a radius is what they gave us here. Now a diameter is going to be equal to 2 of those, a radius and a radius. So we take our radius, 5.1, and we're going to multiply that by 2 to get our diameter, which gives us a total of 10.2. That's our diameter. And then we say 10.2 pi, and probably just leave it just like that. I'm not sure if your teacher would want you to continue that. You could. You could put in an approximation for pi, right? It could be 3.14. You could do 22 over 7. Or you can use your calculator button and press the pi button. Alright, so find out from your teacher what they want you to do there, but you definitely do 10.2 times the value of pi. Alright, that's it for today. Have a great time, a great day, and we'll see you next time.